Hello, in this video, we are going to look at the idea of work in general and how we can use calculus and integrals in determining work or the amount of energy needed to perform a various task. So work is that important concept for determining the amount of energy that's needed. Work is done when a force moves an object. We are specifically going to look at the instances of lifting up a heavy object, winding or pulling up a heavy chain, pumping water up and out of a tank, and stretching or compressing a spring. So in general, if we have a constant force on an object, then the work done is going to be the force times the distance. Just like the mass in the last one was the density times the volume. Now, work is force times distance. Some quick notes on units. Our distance in all of these examples gonna be in meters. Mass is gonna be in kilograms. Force, we're going to use newtons for when we're finding force, and that is kilograms per meter squared, meters per second squared, or mass times acceleration. And then joules are going to be newtons times meters, or joules. So using this idea, suppose we have an object that we just want to move 10 meters. We are constantly pushing or applying this constant force of 3 newtons on the object. How much work is needed to push this box or this object along the x-axis? Well, work is force times distance. We're applying 3 newtons worth of work, 3 newtons worth of force, 10 meters. So this is 30 joules. But what if the force varies? What if, as the object is being moved, at one point the force is stronger than at a different point? Well, that's where the idea of integrals comes in. So we have this box and we're pushing it along the x-axis from a point A to a point B. And at any various point, we have a different force acting on it. In particular, between xi minus 1 and xi, we can estimate the force being done on that small little interval and use that to find the force, we can use the force on that small little interval to find the work being done over that small interval, and use the small interval to then tell us about the whole interval. So if I want the work done over this tiny little interval, then work is force times distance. The force, I could either use the first endpoint or the last endpoint. We're going to use the last one, or we could use any point in between, is estimated with the force that's being used at the point xi. And the distance is that tiny little interval delta x. Similar integral setup as always. Now we have all these little intervals that are the force on that interval times the interval, each of those estimating a little bit of work. We add all those little estimations up. And we take the limit. This is the work being done to push that object entirely. Well, we have the limit of a sum with a delta x. This is just the integral over that interval a to b of that varying force function. So if I want to find the work of an object that's being moved in a straight line from A to B, where the force is varying, work is going to be the integral from A to B of force. In the next example, in the next video, we'll look at work being done on springs and see how we can use this work formula with an integral to find how much work is done to stretch or compress a spring.